This is lesson 6.1, the first video. We'll call it 6.1a. Boy, that's kind of inventive, isn't it? Elementary algebra, reducing rational expressions to the lowest terms. All right, so first of all, what we're going to do is we're going to look at what x cannot be. We're going to restrict what x is and what it isn't. All right, if you remember, a long time ago, probably elementary school, you were taught that if you have a 0 over a number, that equals 0. But if you have a number over 0, that does not exist. This is called the null, N-U-L-L set, or there is no answer. 6 divided by 0 is not 0, it's not nothing, then it does not exist. So, that's a restriction that we put on our math, and that is an important restriction to remember, because if you ever decide to go into higher level math, even college algebra, into calculus, you will use that 0 in the denominator all the time because it means something. And right now it means that you get no answer. So in order for this answer to not exist, x would be equal to 3. So when x equals 3, the answer here is the null set. The answer does not exist. And so we don't want to use 3 as the answer. So the answer can be anything else, but it cannot equal 3 because that makes my denominator 0. Alright, which brings me to a little bit more of a complex number. 5 over x squared minus x minus 6. Alright, what can x not be? Well, we have to simplify that or factor that into two binomials. So if we factor this down into x minus 3 and x plus 2, what will make this denominator 0? Well, if x is 3, then this becomes 3 minus 3, which is 0, and then 0 times, and if this x is 3 too, this will change. Let's just write it down here. This will be 0, and this will be 3 plus 2 is 5. And 0 times 5 is 0. So this 5 would be right there. So we would get as an answer 5 over 0. So x cannot equal 3 because it will make that bottom set of numbers 0 when we multiply. X also cannot be negative 2, because if it was, this would be negative 2 minus 3, and this would be negative 2 plus 2. And then this would be negative 5. Negative 2 plus 2 is 0, and when we multiply those, we'd get a 0 down there in the denominator, and we cannot get a 0. So what I'm saying is there are some numbers that make this answer non-existent, and those are the numbers that we cannot get. So when we say what can x be, well, x can be any number that we want it to be, possibly, but it cannot be 3 or negative 2, because then it makes this original problem not exist. Okay, so anyway, that's just your first set of your first examples there. When you're solving these in the problem set 6.1, you will be asked to simplify the expression. Means give me a simpler version of the number. So for example, in number 1a in the problem set, it gives us 5 plus 1 over 25 minus 1. So 5 plus 1 is 6, 25 minus 1 is 24, and that reduces to 1/4. Okay, so that works great. Well, the next problem they give you is a little bit different because it's not so clean. So b is x plus 1 over x squared minus 1. Okay, so what we're going to do here is the top one is simplified as much as it can. The bottom one is a difference of two squares. So it can be written like that. Okay? And then we have this and this that are the same. So we can cancel that whole thing and that whole thing, the whole group. So that leaves us a 1 on top and an x minus 1 on the bottom, and you're like, oh, cool, I'm done. But you're not done, because x cannot be certain numbers. What if x were equal to 1? We would get 1 over 1 minus 1, right? And that would be 0. And you can't have 1 over 0. So x cannot be 1. And I know this is going to look a little confusing. X cannot be negative 1. Okay. You put negative 1 in here, it works, doesn't it? Negative 1 minus 1 is negative 2. But when you're testing to find out what your x's cannot be, you have to go back to here. You don't cancel. Okay. You cancel to get the final answer, but to determine what x can and can't be, you go to the original problem where we found the difference of two squares and wrote them. But before we cancel things, you have to find out what x can be and what x can't be. So it can't be 1 because 1 minus 1 is 0. It can't be negative 1 because negative 1 plus 1 is 0. So those are the two numbers it can't be, and then we go and cancel and simplify and get that. So what they're saying then for an answer is 1 over x minus 1, and x cannot be 1 or negative 1. That is the answer that they're going to be looking for. Alright, so jumping to example 3, they're asking us to reduce this fraction. And there are certain rules, well, not really rules, but guidelines to make it easier to reduce. So first of all, you look at the numerator and you factor. Then you look at the denominator, then you factor. And then you cross the line and put things together. So let's do that. X squared minus 9 is the difference of two squares. And then x squared plus 5x plus 6 will break down into two parentheses. Two numbers multiplied together give you 6, added give you 5. So 3 times 2 is 6, added give you 5. Alright, so we simplified the top, and then we simplified the bottom. And once you do that, then you look at things that are common so you can cancel. Notice, we are not going to cancel this x and this x, or this 3 and this 3. When you have a parenthesis, everything in the parenthesis has to be the exact same as that. Now we can get an answer of x minus 3 over x plus 2 for our answer. Alright? And just look at this one. What number can x not be? X cannot be negative 2 because when we add those we get a 0, which makes it undefined. But anyway, they're just asking you to reduce, not to tell us what x cannot be. So we'll just leave it at that. Alright, the next one, they give us 10a plus 20 over 5a squared minus 20. Okay, we're going to look at that. We're going to factor. So we're going to take a 10 out, and that leaves me with a plus 2. Here I'm going to take a 5 out, and that's going to leave me with a squared minus 4. Alright, I look at this. That's the difference of two squares. So I get 10 to the a plus 2 over 5, and then I have two parentheses because the difference of two squares, a plus 2, a minus 2. Alright, I can cancel that with that, and 10 over 5 is 2. So that gives me a 2 on top and an a minus 2 on the bottom, and I'm done. Okay, let's look at example 5. And so hopefully you're looking at these going, you know, these are kind of not too bad. In fact, I might even be able to say that I kind of like doing these. 2x cubed, is that a cube? Boy, the writing in this book is so little for old men. Okay. X cubed plus 2x squared minus 8x. Okay, let's look at the numerator. I can factor a 2 and an x out of there. And that leaves me with x squared plus x minus 12. And let's look at the bottom while we're doing this. I can take an x out of there, and that leaves me with x squared plus 2x minus 8. Okay? Now let's go ahead and simplify that. So we have 2x times x minus 3, two numbers multiplied together, added, give me a 1x, and I get that because 3 times 4 is 12. In fact, negative 3 times positive 4 is negative 12. Negative 3 plus positive 4, negative 3 plus 4 is a positive 1, so that's good. Now I look on the bottom and see if that factors into 2. I've got an x there and an x there. Two numbers multiplied together give me an 8, added give me a 2. So the only option I have is 4 and 2. And I need this to be negative. So one of these has to be negative, and I need this to be positive. Okay, so the biggest one has to be positive. So that positive 4 times negative 2 is negative 8. Positive 4 plus negative 2 is a positive there. And now I can start canceling. I can cancel that x with that x, that with that, and I end up with 2 times x minus 3 on the top and an x minus 2 on the bottom. And I'm done. Okay, let's continue with the next video with example 6.